Welcome to Spring Lib.
In this question, the half-life of palladium is given as 4 days. So after 20 days, a sample of palladium 100 was reduced to a mass of 4 milligrams. So what was the initial mass? So if the initial mass was m and the half-life is 4 days, so it means that after 4 days, it will reduce to half of its value, which is m over 2. After another 4 days, it will reduce to half of its value, which is m over 4. Likewise, another 4 days, m over 8, another 4 days, m over 16, and another 4 days, it will be m over 20. So this is 2, 4, 4, 8, 12, 16, and 20. So after 20 days, it has been reduced to 1/20th of its weight, and that's what we have to find after 20 days. So the mass after 20 days, m over 20 is m over 20, where m is where it is given that the reduced mass is 4. It means that m over 20 is 4, which means that the value of m is 80 milligrams. That's what we started. That's what the radioactive element started with. This is the initial mass. So this is part A. Part B is what is the mass 6 weeks after the start. So for 6 weeks after the start, we'll find the equation first, because the equation can now be easily written as m is equal to m naught. So m will say that this amount after any time is m as a function of time, is equal to the initial mass, which is 80, times e raised to minus lambda t, where lambda is the decay constant. And we know that decay constant is nothing but natural log of 2 over half-life, and the half-life is given as 4 days. So clearly this will become 80 times e raised to minus ln 2 over 4 times t times t. Now this is given in terms of days, and we have 6 weeks. So it means that 7 times 6 is 42. So t should be replaced with 42 over here. This will be replaced with 42 because 6 weeks has 42 days. So all we have to do is grab our calculator here and find its value. So 42 times natural log of 2 over 4, and minus of this value, and e raised to this value times 80. So we are left with 0 0.05, or let's call it 0.06, in fact, milligrams is what we are left with uh, after 6 weeks from the start, which is 42 days. Thank you.